Alright guys, this video is going to set you up with how to configure your analog inputs on the LVProSim program. If you're in the intermediate class, this is your last step for this ultrasonic level lab. If you're in the advanced class, we're just getting started, guys. We got to set up our P, proportional, integral, and derivatives after this. But this will set up that signal coming into the software. So right now we have 20 milliamps being shown on the screen. Right here, that 20 milliamps is corresponding to our level of 50 centimeters in the tank. But how do we get this level, percentage, and voltage to come in on our screen here? Well, what I want you to do is go up and go to Setup, scroll down and go to Configure Analog Inputs. And you'll notice that there's a number of different setups here. This is for our lab. If you go back, there's a flow, right? Number of different setups. Let's go back to the one that I've already got set up. So I've got level, and what I literally want you to do is just type in level, and then below you'll see that the maximum is 50, the minimum is 10, and our units are centimeters. Okay, once you've done all those guys, then move across, put in percentage, 100%, 0 for the low, or percentage for the units. Now, right here I'm showing that the 0 will be there with the initial setup. I want you to get rid of that filter time constant on each of our inputs there. Okay, so we'll get rid of that. And lastly, we're going to do our voltage. So we got 5 volts for the max, 1 volt for the min, and obviously our units are in volts. Now what I'm showing here is that our voltage is 1 to 5 volts DC coming into the software. So for analog inputs 1, 2, and 3, I want you to put that X there for the 1 to 5 volt signal. Otherwise you're going to get a 0 to 5 volt signal. So again, you're going to toggle the 1 to 5 volts right across. Okay, once you're done that, then I want you to go up and hit File, hit Accept the setup, and return to the trainer. Yeah, everything looks good, so we'll hit Yes. As soon as you do that, you should have the same things as I do. The level, the percentage, and the voltage come in. Okay, so what I'm showing now is I'm taking that conductor and I've moved it from the first analog input and I've moved it over to the second analog input. You can see that my signal has disappeared on the first input and it's now coming in on the second input. Okay, we're at the highest end of the range, so we're hopefully seeing 100%. I'm off by a touch, but this should be 100% for our value. Okay, then we're going to move over to the next input. So I've removed that terminal from the second, I've moved it over to the third input, and we should see 5 volts DC now on our third input. So I'm physically taking that wire from the first input and moving it over to the other two inputs to show you that 50 centimeters is corresponding to 100%, which is also corresponding to a 5 volt signal. Okay, so now we'll bring in the 50 centimeters again. And what I want you to see here is that I'm going to place a jumper between each of those terminals now. And you'll see that the centimeters goes down. So the voltage goes down for some reason as soon as I parallel these inputs. Okay, so there's my second input. There's my third input. And you can see that the voltage has now dropped across. I'm at 97, I'm only at 4.91. So this is kind of a pain with this software in that when you physically try and have a number of different signals come into this software by paralleling them up, in parallel the voltages should be exactly the same. There shouldn't be a voltage drop like this. But when you look at a number of different factors here, by jumpering your inputs across, then you will find that the voltage drops down just a touch. Okay, so now we've got 50 centimeters corresponding to 100%. We have that as a 5-volt signal, and now I'm going to start to drop the level of the tank down, and you'll see that each of the values goes down at the exact same amount. Going down now to 40 centimeters here. Okay, 40 centimeters is 75% of our range. You can see that because those jumpers are across, it should be 75%, right? Should be 40 centimeters and should be 4 volts. But because I've jumpered those across, the values are skewed a touch. Okay, you can see here that once I take the other two inputs away, the voltage goes up by a touch, and now I'm closer to 40 centimeters. Put them back in, and all of a sudden it drops down again. Okay, so now we're dropping down to 30 centimeters. 30 centimeters is going to be half of our range. Okay, so we should be at 50%. Again, we're a little bit lower because of that voltage drop, but that should correspond to a 3-volt signal coming in. Okay, take that away and you can see that the voltage bumps up again. But I want to see all 3, so I don't mind that small deviation in my values. Okay, now we're going to drop it down to 20 centimeters. Okay, 20 centimeters should correspond to 25%. I missed the mark a little bit there. Should be 25, and that should be 2 volts as well. Then finally, we're going to drop her down to 10 centimeters. 10 centimeters is 0% and should correspond to a 1-volt signal coming into the computer. Excellent. So now we've been able to walk through and we've found each of our different values right across. We're sending a 1 to 5 volt signal into this program, and by configuring our analog inputs, we can keep track of our values and see exactly how that 1 to 5 volt corresponds with percentage and our levels that we set between 10 to 50 centimeters. Alright guys, thanks for your patience on this. Next videos I'll show you how to set up the trend recorder to keep track of our values as they change, and we've also got to do our PIDs.